Hello, viewers. How are you all today? Peace be unto you, folks. This is a Mysterious Universe channel. We brought you a video which talks about the connection between the universe and our brain. Could our brain be identical to the cosmos quantumly? Before watching our videos, we urge you to click the subscribe button and the bell sign consecutively to subscribe to our channel in order for us to bring you more related science videos on time. Now let's dive to the video. Scientists discover possible connection between human brain and cosmos on a quantum scale. The human brain, with its intricate networks of neurons, has long been a subject of fascination and mystery. Concurrently, the cosmos, with its vastness and complexity, has intricate sciences of the universe, and recent research has begun to explore the possibility that the brain and the cosmos might be connected on a quantum scale. This article will develop into a research paper titled Quantum Transport in Fractal Networks and discuss its implications for our understanding of the relationship between the brain and the cosmos. Quantum Transport in Fractal Networks. The research paper, Quantum Transport in Fractal Networks, explores the possibility that the brain and the cosmos are connected through a fractal network. Fractals are self-replicating patterns that can be found in various scales, both in nature and in the universe. This study investigates the quantum transport properties of fractals, especially focusing on how electrons and energy move through sense networks. The authors demonstrate the quantum transport in fractal networks exhibits unique behavior, which could have significant implications for our understanding of the brain-cosmos connection. Implications for understanding the brain-cosmos connection. The findings of the research paper provide valuable insights into the possible connection between the brain and the cosmos on quantum scale. The unique behavior exhibited by the quantum transport in fractal networks could potentially explain some of the brain's complex functions and its connections to the universe. For example, the fractal nature of both the brain's neural networks and the cosmic structure might indicate that they are governed by similar principles. Understanding these connections could lead to a better understanding of the fundamental mechanisms that underlie consciousness, cognition, and perception. Potential applications and future directions. The research on quantum transport in fractal networks has several potential applications and opens up new avenues for future studies. For instance, this understanding could have implications for developing novel technologies that harness the power of quantum mechanics, such as quantum computing or quantum communication. Additionally, the study of fractal networks could lead to advancements in our understanding of complex systems, such as the human brain or the cosmos, and how they function at their most fundamental level. Conclusion: expanding our understanding of the universe. The research article Quantum Transport in Fractal Networks presents a fascinating exploration of the potential connection between the brain and the cosmos on a quantum scale. It highlights the unique properties of quantum transport in fractal networks and their possible implications for understanding the brain-cosmos connection. By further investigating these connections, we can expand our understanding of the universe and the nature of reality itself, potentially having the way for new groundbreaking technologies and insights into the mysteries of the brain and the cosmos. That was what we had for you today, folks. Please put some comments about the video if you have any, and don't forget to share and like our videos. Please keep on subscribing to our channels so that we can bring you updated news about science and the nature. Thanks for watching again. Bye for now.
If you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for you.
It's as if the particles are aware they're being observed. Then physicist John Wheeler had an idea. He called it the delayed choice experiment. How it works is photons are projected through the double slit, but the detector is not activated until after they pass through the slit, but before they impact the screen. Photons were emitted as waves, passed through the slits as waves, but when the waves were observed before hitting the screen, they suddenly behaved like particles again. Still don't think there's an intelligence at work? Well, what Wheeler's experiment showed is that even though the electrons started as waves but behaved like particles after being observed, at the moment the decision to observe them was made, the electrons recorded themselves as having passed through the slits as particles. The electrons changed their state by going back in time.
I personally find that I gravitate more towards the information theoretic point of view and believing that the universe that I exist in is a very good, high-quality simulation.
Now, this experiment is happening on a table in a lab, a very short distance. So what happens when we observe light coming from vast distances this way? They reach back through time 100 million years and alter their state on the other side of the galaxy.